Okay. Okay, you can give me countdown. Very good afternoon to all of you, and welcome to today's coaching class. And we are completing the chapter on probability today. So,
recording in progress.
We had discussed in the last session about the concept of probability, and we are following the study material to understand each of these concepts in detail. We had discussed about what do we mean by an experiment. That is the first concept we learned is what is an experiment. An experiment can have certain outcomes, and these outcomes are known as events. And thereafter, we discussed about the definition of probability, after which we discussed additionally the three important related concepts. First is events need to be mutually exclusive. What happens when events are mutually exclusive? We learned about that. And then the definition of exhaustive set of events. Mutually exclusive, you remember that if one event takes place, the other cannot take place. For example, in case of a tossing of a coin. Exhaustive means if, say, for example, and there are for an experiment, if there are two outcomes, that means these two outcomes together, the probability of these two outcomes together will be equal to 1. Why? Because exhaustive means that all these outcomes put together is the complete sample space of that event. We additionally took up the discussion of equally likely events, and then we discussed about conditional probability. If you refer to the discussions we had, after conditional probability, we had discussed about the De Morgan's law. We learned about De Morgan's law, and we have seen that the concepts we learned earlier in the set theory is very important for our problem solving on this chapter. Lastly, we had completed in the session we had completed with a lot of examples from the exercises given in the study material, and additionally we have taken some examples from the additional question bank and the mock test paper. So today we are taking up first some FAQs. Now, yes, certain questions have come which I will just try to respond. Do we have to do additional question bank of mathematics and statistics? Yes, it is important. You will find in several chapters of mathematics and statistics, there is an additional question bank. So please go through the questions, try to solve it, and please check your answers with the solutions which are given. The second question was regarding, is probability used in data science? Yes, probability is used in data science as well, and it is quite important for CS. Especially we discussed about the applications of probability in financial modeling, artificial intelligence, and big data. Is probability all about future events? Another interesting question came, is probability all about future events? Yes, probability is based on the past trend, but then it is based on events. Okay, then there was a question regarding RTP and MTP. MTP and RTP are very important. Please go through the institute's material in detail and additionally try to solve the questions from the revisional test papers and the mock test paper. We have taken several problems from the mock test paper when discussing the various chapters and the related concepts. There was one question, could we say that business is an experiment? Yes, from the statistical point of view, business is an experiment. Like we were discussing, that any experiment will lead to certain outcomes. Okay, it will lead to certain outcomes, and therefore it is true that a business can have success or failure. If you can define it specifically, then business can be termed as an experiment from the statistical point of view. Another interesting question was regarding, is mutually exclusive and disjoint the same? Well, if you draw a Venn diagram, you will find that mutually exclusive means if one event takes place, one outcome taking place, the other outcome cannot take place. For example, in an exam, there could be two possible outcomes. One is passing and the other is failing. So if someone has failed in the exam, that means he has not passed. So the occurrence of one event automatically results in the fact that we cannot have the other event. So that is mutually exclusive. Disjoint, yes, when we draw a Venn diagram, if you find that two circles are not intersecting, if we draw two circles separately, it is disjoint. That means they are mutually exclusive. And we remember, in case of mutually exclusive events, A and B, in such a case, A intersection B will be zero. There will be no common parts between A and B. Now, there was one question, PAB. Can we take it as PA union B? No. It is PAB is usually the best way to describe probability AB is probability A intersection B, and it can be in case of conditional probability, P intersection B, PAB is equal to PA multiplied by the conditional probability of B, considering that event A has already occurred. Okay, then there was one important question, frequently asked question is, how can we know that the particular event is independent or not independent? In many cases, the answer is in many cases, it will be mentioned in the question. So you need to see the language in the problem which comes in the exam. Now, how exhaustive is different from mutually exclusive? So through these FAQ, through these frequently asked questions, we are also trying to understand. We are understanding the different, the recap. We are going through a recapitulation of the key concepts in probability. How exhaustive is different from mutually exclusive? Okay, how exhaustive is different from mutually exclusive? So exhaustive events. So exhaustive events means the events A1, A2, A3 are known to form exhaustive set if one of these events must necessarily occur. So if we have a tossing of a coin, for example, there are two events, head and tail. So these are exhaustive. Why? Because one of these events, either head or tail, has to occur. There is no possibility of any third event happening. Similarly, when we are, say, flipping, when we are rolling a dice, we can get any score, 1, 2, 3, 4, 5, or 6. But the probability of getting a score of 7 when we roll a dice is 0. It's not possible. So therefore, when we are rolling a dice, it is definitely an example of an exhaustive event because any of these events must occur. One of these events, one out of, you can get 1, 2, 3, 4, 5, or 6. So one of these events must necessarily occur. So that is an exhaustive. And equally likely, we had discussed about equally likely, also known as equally probable events. The two events, head and tail, when a coin is tossed, is an example of a pair of equally probable events, because in both the cases, the probability is same. The probability is half, 0.5. Similarly, when we roll a dice, the probability of getting a specific number, say a score of 3 or score of 4 or 5 or 6, for example, is equal to 1 by 6. So in the case of rolling of a dice, unbiased dice, it is definitely an example of equally likely events. Then what is PAB? That is compound probability or joint probability. That means just a quick recap of this important concept, probability, joint probability. So the probability of occurrence of two events A and B simultaneously is known as the compound probability or joint probability. And the formula you remember is PAB equal to PA into PB. This is for independent events. But if it is dependent, so that means the occurrence of event B is influenced by the occurrence of event A. In that case, that will be termed as dependent events. In case of dependent events, we know that PAB is equal to probability of A multiplied by probability of B by A, or we can put it in this way, probability of AB is equal to probability of B into probability of A by B, assuming that B has occurred. What is the conditional probability of event A? So please remember these two formula, which you can see on this slide, and we had discussed this in detail in the last session as well. And theorems of compound probability also we had covered. Okay. Mutually exclusive and independent event. What is the difference between mutually exclusive and independent events? Mutually exclusive event means when one event takes place, the other event will not take place. And independent event means the occurrence of one event has no impact on the occurrence of another event. So that is called independent event. For example, when a coin is tossed, tossing of a coin, there are two mutually exclusive events. One is head and the other is tail. Okay. So in case of Venn diagram, as I was mentioning earlier, that when we are drawing, if you draw two circles which are not connected to each other, they are not intersecting each other, that means this is like a situation where there will be no connecting points. There is no common point between these two circles. There is no common portion between two circles A and B. So this is an example of mutually exclusive events. And please remember, for mutually exclusive events, PA union B or PA plus B is equal to PA plus PB. Why? Because in case of mutually exclusive events, PA intersection B, that is the probability of A intersection B, is 0. Why? Because these two events cannot occur simultaneously. If one event takes place, the other event cannot take place. Okay, so please remember this particular formula which we had discussed in the last session. What is sample space? Sample space means the totality of all the outcomes to an experiment. And sample space, for example, when you are tossing a coin, the sample space will be head and tail, H and T. When we are rolling a dice, the sample space will be composed of a score of 1, 2, 3, 4, 5, and 6. So the total probability of the sample space has to be equal to 1. So this can come sometimes, this is a very important concept from the question point of view. If a question comes that the total probability of a sample space is what? Is it 0? Is it 1? Is it, say, half? Or is it not any of the above? So the answer is the total probability of the sample space is probability is equal to 1. The total probability is equal to 1. So this is sample space. We had discussed about this. De Morgan's law, again, we can see graphically. The De Morgan's law states that A union B complement is equal to A complement intersection B complement. So you can see the left hand side, A union B complement is equal to A complement intersection B complement. Okay, so this is very, very important. And we had solved similar problems from the exercises based on De Morgan's law. So kindly go through that once again for your review. And this is the graphical presentation of De Morgan's law. Now we move into random variables. So we are completing the second part of probability today. And after discussing all the important formula and the technical concepts, starting with mutually exclusive, exhaustive, equally likely, conditional probability, then De Morgan's law, we are now discussing about random variables. Now, what is a random variable? So, in measurement, when we take measurements, well, we have different values on different occasions. For example, the height of a person, the profit of a company, atmospheric pressure, temperature. So these are variables because these will provide different values on different occasions. So these values are subjected to random variability. Why? Because they are not completely predictable. So that is why it is known as random variables. And we will see that random variables have two types. One can be a continuous variable, continuous random variable, and the other can be a discrete random variable. And you remember in statistics earlier, in the measure of central tendency and in the chapter on dispersion, we had discussed about discrete variable and discrete distributions, and we had discussed about continuous distributions, frequency distributions. So the same concept will carry on. We will have the same concept, no change in our idea, the same idea which we learned, the same concept which we learned in the chapter on dispersion. We will discuss it once again. So random variables means any variable which can take up different values. It can take up different values, right, on different occasions. So it can be, as I said, the income of a person, the profitability of a company. Sometimes there might be high profits. Sometimes there could be low profits. So in certain cases, there can be loss. So the amount of profit will go on varying from year to year. So it's a random variable. Why? Because it is not completely predictable. You cannot predict with a certainty. Now, examples are crop yield, crop production, the maximum temperature, for example, number of cyclones in a season. So these are the examples which are there in the study material also. We are strictly following the study material so that we understand each of these important concepts. If there rain or no rain, the measurement of the amount of rain. So this is also not completely predictable. So therefore, this is an example of a random variable. So random variable means any variable, any value which might change, a measurement whose value will change from time to time on different occasions. Like, for example, just imagine the temperature during the day. Is it a random variable, temperature? So if you think, yes, temperature is a random variable, why? Because temperature, what happens is the temperature changes throughout the day. So in the morning, the temperature is high. At noon, it becomes the highest. Again, in the evening, the temperature reduces. So if you are doing a mapping, a measurement of the temperature during the day, you shall find that temperature is variable. So it's a random variable because it is not completely predictable. Now we have two types of variables. First is continuous variable and the other is discrete random variable. Right? So what is continuous and what is discrete? This is a vital concept which we need to understand. Now, a continuous random variable is one which can take any value within a defined range, right? So please focus on the presentation slide and try to understand these important concepts. So a continuous random variable means it can take any value within a defined range. So let us take a very common example, crop yield. Or again, I will take maximum temperature, pressure. Now the atmospheric pressure can take any value, including fractional values. It can take even fractional values. Temperature can take even fractional values. It can become negative also. So we can easily understand that these parameters, these measurements like temperature, pressure, crop yield, etc., can take any value within a defined range. So if I say that between the range 0 degrees and 25 degrees Celsius, so I'm talking about temperature. So the temperature in a particular location can take, technically it can take any value. It can be, for example, 19.22227 degrees Celsius. So if I say a temperature in a hill station during winter, well, it can take any value even in the negative. Below zero, for example, there could be places with a temperature of -10 or -9.9974, something like this. So the temperature, pressure, these variables, weight, these can assume any value within a defined range. So that is why these random variables are known as continuous random variable. The electric voltage, for example, here again, you can see, there's one, Shiva, you are correct. Temperature is a random variable. Absolutely. Samir has said, yes. Shiva has stated that because the temperature keeps changing. Absolutely. Right. So Bhumika has also agreed that yes, temperature is a random variable because it changes. The weight. Now, if I talk about a situation like, say, the atmospheric pressure also, the pressure will change from place to place. Now, the atmospheric pressure during say, for example, in Delhi, and the atmospheric pressure in Shimla, for example, could be different. The atmospheric pressure at Mumbai near the sea and the atmospheric pressure at Ooty, which is at a high altitude, will be different. So from place to place, the pressure can assume different values. So if you get a question like this in the exam, that temperature and pressure are examples of what type of variable, the answer is it is a continuous random variable. Similarly, electric voltage can move up and down. So even voltage is an example of continuous random variable. Now, dear students, please see the concept of the definition of discrete variable. Discrete variable is what? A discrete variable only has a countable set of values. That means it will be possible to count. For example, number of cyclones. Now just imagine, can the number of cyclones be negative? Can I say that we had -5 cyclones in the western part of India? Can we say that? I think no. Similarly, cyclones can never assume a fractional value. So I hope you can easily understand this, that there are certain types of, yes, climate. Ankit has talked about climate, yes. So counts like the number of cyclones, it has to be positive. It can be a very high number. In certain parts of the world, there can be frequently, almost on a daily basis, there could be cyclones and tornadoes, right? Especially coastal areas. There could be high frequency. So there may be quite a high number of cyclones, but it will always be a whole number. It cannot be negative. It cannot be a fractional number. Similarly, if we take the number of scratches on a surface, right? You take the third example, number of scratches on a surface. So the number of scratches on a surface, either it's a whole number, either you have a scratch or you don't have a scratch. You cannot get a fractional number. You cannot get a negative number. So number of scratches on a surface, yes, it's a variable. It's a random variable. Why it's a random variable? It's a random variable because the variable, the measurement of the variable cannot be predicted with certainty. So therefore, the number of scratches on a surface, say you are sitting near a table or at a desk. So if you find out how many scratches are there on the desk or how many scratches are there on the table, so you will get a whole number. It cannot be negative. You cannot have -3 scratches. Similarly, you cannot have 2.7 scratches. Sorry, it's not possible. So it has to be positive, right? So I hope you're understanding. Number of scratches is an example of a discrete random variable. The next example, number of defective parts per 1,000. Just imagine that there's a factory and say the factory is manufacturing, say for example, let's take a very common example, say it's manufacturing cars. So think of the manufacturing plant of Maruti or Honda or Hyundai or Kia, whatever, right? So say for example, there is a manufacturing process. Yes, there's one example, I think Priyanka has written thunderstorm in Rajasthan. Yes, thunderstorms in Rajasthan, absolutely. So it could be seen as definitely it is a discrete variable. Okay, I will take the question from Manisha and Samir. Great. Height is a discrete variable, absolutely. Priyanka has added one more point. Height is discrete. In fact, the height within, now the question is height discrete? That's a big question. Can height take fractional value? Answer is yes. So height will be a continuous random variable. Because you can have a person who is, if you really measure the height with accuracy, you can get a person, say, 5 feet, 10.2235 inches. It's possible. So height is a continuous random variable. Yes, you can say that height cannot be negative. Absolutely. So within a defined range. So if I want to just say, this is in response to the point raised by Priyanka, she has, I think, this is from Priyanka Jha. Yes, Priyanka Jha has said height is discrete. Now, height, please note, is continuous. It's not discrete. If I say that the height in a class, say I go to a CA foundation class and I just give a range. Okay, say the lower limit of the height is 4 feet 8 inches and say the upper limit I keep at 6 feet. Okay, someone very tall, 6 feet. So the lower range is 4 feet 8 inches and the upper limit is 6 feet, right? Okay, just imagine, highest is 6 feet, lowest is 4.8. These are the ranges. Within this range, say there are 50 students in the class who are all studying, like you, say it's a CA foundation class going on. Now, if I take the height, if I measure the height of each student, and I know that the shortest student is 4 feet 8 inches and the tallest student is 6 feet. This I know. So I've created the upper limit and the lower limit, the upper boundary and the lower boundary, right? So now when I take the height of each one of the student, well, the height can have any value between these two ranges, 4 feet, 8 inches and 6 feet. So the height of any person, say the 25th or say 27th student in the class, out of 50, randomly I'm choosing the number 27. So the height of the 27th person can assume any value between 4 feet 8 inches and 6 feet. So therefore it can be a fractional value as well. So height is a continuous random variable. Yes, it is true that height cannot be 0 or height cannot be minus in negative, but yes, height of a person can assume any value within a defined range. Now let's come to the number of defective parts. Say a car is getting manufactured, 1,000, say in one day, the company, the production factory is able to manufacture 1,000 cars. Now out of 1,000 cars, some cars will have some defect. So the number of defective cars, can it be negative? What do you think? Number of defective cars, can it be negative? Answer is no. Can the number of defectives be 0? Answer is yes. For example, on a particular day, not even one car is defective. That means the number of defectives is 0. That means number of defective parts or the number of defective cars in a production facility can assume any value starting with 0. There can be 0 defects, there can be 1 defects, there can be maybe 200 defects out of 1,000. So in case of number of defective parts, it is, please remember, it is like a discrete random variable because it can assume only whole numbers, including 0. It cannot take a fraction, it cannot become negative. You cannot have minus 7.5 defectives, it's not possible. So it can be 7 defectives, it can be 8 defectives, but it cannot assume a fractional value, right? Good. Now, therefore, okay, let me take the next point which some of the friends have written. Age is a continuous variable. Okay, Manisha has written this. Is age a continuous variable? Well, age of a person can vary. Absolutely, age of a person can vary. But the question is, age of a person will vary only within defined range. Okay. For example, the age may not be more than, say, the oldest surviving person is, say, 115 years old. So it's not possible to get a person who's having an age of 150 or 180 or 200 years. Not possible. So age has a range. Similarly, age, say a newborn baby has an age of a few minutes or maybe a few hours. It cannot be negative. But within this defined range, age can take a countably infinite number of values, you can say. So in terms of if you try to measure the age of a person in years, in months, say someone is 31 years, 9 months, 15 days and 4 hours old. So you can get that type of situation. So age ideally will be seen within a defined range. It can assume all values. It can be fractional as well. So technically speaking, age will be a continuous random variable because within a defined range, of course, age cannot be less than 0 and age cannot exceed a certain limit. For example, 115 years or 120 years, for example, maximum longevity of a human being. So not beyond that. So within this defined range, age can take almost any value. So it can be seen as a continuous random variable. Okay, then one more point has come. Let me check. Height is a continuous random variable. Shiva has said, yes, height is a continuous random variable. Color of a flower is discrete. Okay, this has come from Ankit Kumar Mishra. Color of a flower is discrete. Well, you see, we have to measure. See, discrete and continuous random variable means we are talking about measurement. Now, the color, if you see, is an attribute. It is qualitative. It is not quantitative, right? So color will be an attribute. We cannot think of color as continuous or random. Okay. Let me see some other views. Road accidents is continuous variable. Okay, who has said this? Jyoti Jha. Okay, Jyoti has taken this point. Road accident is continuous variable. Jyoti, I will request you to think. can road accidents take negative values? No. You cannot have -2 accidents? No. Can road accidents take fractional values? For example, can I say that in this year or in this month of February, today being the last day of February, can I say that in the entire month of February, the number of road accidents in Delhi is 3,527.35? Can I say that? No, I cannot say that. We cannot have fraction, right? So please understand the nature of this number of road accident. It is a discrete random variable. Yes, it has a range. It cannot be negative. It can only occupy whole numbers, but it can assume a countable set of values. So it's a discrete random variable. Then there is one more point, right? Road accident I have taken. Yes, number of COVID-19 cases in India. And number of weapons in a country. Let me see who has said this. Bhumika. Thank you, Bhumika, for giving us 2 further examples. See, the more we discuss, the more we focus on the study material concepts which we are doing now, the more your understanding becomes strong. So any question which might come on the theory part or on the practical part, you will be able to handle. Number of COVID-19 cases in India. Well, can it be fractional? No. Can it be negative? No. It can assume a high value, no doubt about it, but it will always be discrete. It's a whole number. Okay, so number of COVID-19 cases in India will be a discrete random variable. Number of weapons of a country. Now already you have seen that there's a war breaking out at Ukraine and the whole world is concerned. So when we think of war, we think of weapons. Now, can the number of nuclear weapons or the number of arms, say rifles or say machine guns or tanks, for example, say for example, the assault missiles which countries have, the number of fighter aircrafts, right? Can it be negative? Answer is no. Can it be fractional? No. So it is a discrete random variable. It can take only whole numbers. Okay. Yes, age, who has said, Shiva has said correctly, age is a continuous random variable. Yes. Drinking of tea. Mayur has said, drinking of tea, this is an attribute. Okay. Number of COVID cases, yes, absolutely right, Priyanka. Number of COVID cases is discrete. Population of India is discrete. Let me see who has written this. Population of India. Bhumika, absolutely correct. Yes. Demand is a continuous variable. Well, this has been written by Priyanka. Now, demand of what? If I say demand for, say, now for certain items, it can be a whole number. For example, if I say that the demand for medicines, now the number of, say, the demand for tablets, okay, the demand for, I'm talking about capsules and tablets, medical, for your medicine. Now, this has to be discrete. Number of tablets, you cannot have fraction, you cannot have negative. Similarly, say if I say the demand for, let's say, computers. Demand for computers. This demand for computers will be variable, so it's random variable. Is it continuous? No. It is discrete because number of computers, the demand will be only in whole numbers, right? Similarly, one more point from Archana. Sensex. The sensitive index, Bombay's sensitive index is discrete. Absolutely, you are correct. Number of nuclear bombs in a country from Samir Singh. Yes, Samir, you are correct. It's discrete. So good, we have understood continuous and discrete. Now let us take the next discussion in our module, in our chapter, that is probability distributions. Okay. So let us look at the types of probability distributions. Now, if we measure a random variable many times, then we can build up a distribution of the values. So say, for example, when we are measuring any variable, say the height of a person, or say we are assuming we are measuring the number of accidents, road accidents, the number of COVID cases, okay, it can take up different value. So probability distribution, so let's take a simple example. Imagine a distribution of values which we can take. So the more number of observations we try to consider, there will be certain number of, say we are throwing a pair of, we are throwing a dice. we are rolling a dice. So as we go on rolling the dice, we will get an idea how many times 1 comes, how many times 2 appears, how many times 3 appear, how many times 4 appears, and so on. So the range is from 1 to 6. So when you count these, you will get a probability distribution. So this is the concept of probability distribution. So for example, if you are throwing a coin or a dice 50 times, you will be able to count that how many times we have got. If I say how many times we have got 5, how many times we are getting 4, how many times we are getting 2. So from this, from the number of times, you can find out the probability, and this is called the probability distribution of the variable. So a probability distribution, you will see it will also have mean, median, mode, and standard deviation. So from this understanding of random variable, see, a random variable can take any type of values if it is continuous, and if it is discrete, it can only take countable number of values, right? So this is what is meant by probability distribution. These variables, when you put them along with, when you measure the probability of these, of the occurrences of these events, then you get a probability distribution. In case of probability distribution, again, we will take some examples. First is the discrete probability distribution. Now, a discrete probability distribution means the probability, if you see, say, let us take the example, the random variable of rain or no rain. So, say, for example, the probability of rain is 0.2 and the probability that there is no rain is 0.8. So, if you go on measuring how many days you are getting rain, how many days you are not getting a rain, you can build up a probability distribution, right? So, this is the basic concept of probability distribution. Then the next example, number of sunny days in a 10-day period. Okay, so you can find out the number of sunny days in a 10-day period. Maybe the probability of getting 0 sunny days is, say, 0.1074. The probability of getting x equal to 1, that is 1 sunny day out of 10 days, say it is 0.2684. So in this way, you can measure the probability and the event. 0 events, 1 event, 2 events. Okay, like we were discussing about number of defectives. So 1 defective, what is the probability? 2 defective, what is the probability? So this chart which we are creating, number of events and the probability, this gives us a probability distribution. Okay, the total probability in that case will always be equal to 1, no doubt about it. And 2 important discrete probability distribution, which you will be studying after probability, after we complete this chapter. In the next session, you will be studying binomial distribution and Poisson distribution. So this chapter of probability is ending basically with the understanding of probability distribution, right? So that's why we discussed in detail about the different types of discrete variable and continuous variable. Okay, some more examples have come. Share market is continuous variable or discrete. Now Priyanka has written this, share market, Sensex. Well, Sensex can take, if you see, it cannot take negative values. So ideally, it is going to take within, it can take any possible value within a particular, you can say particular interval or a particular range. So ideally speaking, technically, it is a continuous random variable. Next point is budget is continuous. Priyanka Jha has written the budget of a company. Now, when there is a budget of a company, say the production budget, how many items to be produced? Well, it has to be discrete. Why? Because production cannot be in fraction. You cannot manufacture, for example, 1,000.5 articles, either 1,000 articles or 1,001. So production budget will be a discrete. Okay. So production is continuous or discrete. Again, the same question has come from Ankit Kumar Mishra. Now the production will be discrete because production cannot assume negative value. Production only assumes countably finite number of values, so it will be a discrete variable. Recovery of COVID patients. This has come from Shiba. Recovery of COVID patients. Well, recovery can be a whole number. How many people are recovering? Now, the recovery in terms of absolute number of persons who are recovering, well, that is always a discrete variable. The number of people who are recovering from COVID cannot be negative, it cannot be fractional, right? So from this concept of discrete and continuous, we are also getting the probability distribution, and that is continuous probability distribution and discrete probability distribution. So when we are discussing continuous random variable, then you are getting a continuous probability distribution. Example which we will study later is normal distribution. Okay, and this is again the chapter on the next. Basically, you will be studying this in the upcoming chapter on probability distribution. Okay, an example of continuous probability distribution is normal distribution, and examples of discrete probability distribution is binomial and Poisson distribution, because they deal with discrete variables, and normal distribution deals with continuous variables like height or weight or pressure or temperature, like that. Okay. So random variable, again, we can see if a coin is tossed 3 times, okay, and if X denotes the number of heads, then definitely X is a random variable. So what is the sample space? The sample space for getting the possible sequence, the possible events. Now you are tossing the coin 3 times. You are tossing the coin 3 times. So it can be head, 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 H, H, H. It can be head, head and tail, H, H, T. Okay. It can be H, T, H. You can see all these points here. I'm just moving the cursor here. H, 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 T, H, T, H, head, tail and tail, tail, head and head, all these. And from here, if I say that what is the probability that X is equal to 0, that means X is 0 means number of head is 0. So the probability that number of head is 0, please note, there is only one situation when the X is equal to 0. The value of X is 0 only when we are getting tail, tail and tail. If X is equal to 1, then what does it mean? It means X is equal to 1 means the probability of getting 1 head. 1 head means how many tails? Just imagine, just try to find out. There are 3 times you are tossing the coin. If I say that how many times, or if you get 1 head, for example, you are tossing the coin 3 times, you have to get 1 head. That means what? You will get 1 head means the 2 remaining tosses will end up in a tail. So either the sequence can be head, tail, tail, HTT, it can be tail, head and tail, or it can be tail, tail and head. So in this way, we can find out basically we are creating a probability distribution. Now, what is the difference between discrete random variable and continuous random variable? Once again, please note, random variable is defined as a discrete random variable, when it can assume finite number, or we can say countably infinite number of values. Countably infinite. It is infinite, but it can be counted. So examples, once again, number of car accidents, number of COVID patients, number of heads are always examples of discrete random variable. Okay. Recovery from COVID, yes. Stars in a sky is an example of discrete. Okay, this is a nice one. Sarvesh has written this, the number of stars in the sky. Now, that's a very interesting point he has raised. Number of stars in the sky. Please see this last point, this last line. Discrete means what? It is either a finite number or a countably infinite number. Countably infinite. So the number of stars in the sky, can it be negative? Answer is no. Can it be fraction? Answer is no. So it is countable but infinite. There are millions of stars. We don't know, in fact, how many stars are there. So if you think of the stars which we have been able to identify, it could be a huge number. It may take years to count the number of stars. So it's countable but infinite. So it's a discrete random variable, right? Great. Excellent. Thank you, Mansi, Priyanka and Bhumika for your comments. Now, a continuous random variable. So once again, we recap what is continuous random variable. So it is uncountably infinite number of values, like height, weight. We cannot count it. It can take any value. So it's just impossible to count. Uncountably infinite number. It's a large number and it's not countable. That's why we call it uncountable. Height, weight. These are always atmospheric pressure, temperature. This can assume theoretically it can take any value. Okay. Now we take one more example because this comes as a question. Odds in favor of event A. We are recapping, just a quick recap of the key concept. The ratio of the number of favorable events to the number of unfavorable events is known as odds in favor of the event. And please note, its inverse ratio is known as odds against the event A. Okay, so just imagine I'm giving a small, just listen to me very carefully. I'm just giving a small example. If I say that the ratio, say for example, I say that the odds in favor of a person passing the exam, the odds in favor of a person passing the exam is 7:5. If I say that the odds in favor of a person passing the exam is 7:5, please note it, 7:5. The odds in favor of a person passing the exam is 7:5. 7:5. Then what is the probability that he will fail in the exam? So let me see who can write this answer fastest. Okay, 7:5. Yeah, Manisha, you have said upload previous year's papers. Yeah, I will just try and upload the previous year's papers. Okay. Jyoti, we are doing the theory. Yes, we will also go to some remaining questions of probability. Don't worry. We are first understanding these important concepts once again. And you see, we have covered a very interesting concept of continuous and discrete random variable. And then we will go into the practicals also. So can someone answer this question, that if the odds in favor of a person passing the exam is 7:5, then what is the probability that he fails in the exam? So in this case, yes, 5:7. Great, very good. Okay, 5/12.
Sorry to interrupt you, sir.
Yes, sir.
Regarding the old question papers, we don't have, actually, institute side, we are not uploading anything.
Okay, sir.
Maybe getting from our other sources, maybe there.
Okay,
but
sir.
From institute side, we are not uploading any kind of things.
Okay, sir. Okay, sir. I will inform. Okay. So, dear students, please note that from the institute side, we are not going to upload any previous year's question. You may get it from elsewhere, from other sources, but we are not uploading the past year's question papers. But definitely the MTP
especially for the paper 3 and paper 4 only. Okay,
for paper 3 and paper 4, please note that we are not uploading any of the past year's questions. I was just informed by our senior faculty from the Board of Studies for Mathematics. So he has just informed me that we are not uploading any questions, the past year's questions for paper 3 and paper 4. But the mock test paper is available, I think, in the institute site. Please go through it. And the question papers of the previous years, you may get it from other sites or from other sources from elsewhere. Okay. Now, this question which I was raising, that the ratio, the odds in favor of passing an exam is 7:5. So what is the probability of failing? So you can see 7:5 means the probability of passing is 7 divided by 7 plus 5, that is 7/12. So if the probability of passing the exam is 7/12, then the probability of failing is how much? 1 minus 7/12, that is 5/12. So many of you have answered it. And Jyoti, Priyanka, Manisha, Himanshu, Jain, they have all answered it. So the answer also, we have Bhumika who answered. So the answer is 5/12. Okay. Then again, please see this important formula before we move into the remaining questions from probability. P A union B is equal to P A plus P B minus P intersection B. But if you get a situation where the events A and B, okay, the two events A and B, if they are mutually exclusive, then what happens? That means P probability of A intersection B becomes 0. So therefore, there will be the simple formula. The formula becomes even easy to remember. P A plus B will become probability of A plus probability of B. Okay. And conditional probability, we have already discussed earlier, PA into PB/A. The last one, the last theoretical, conceptual, technical point which we need to discuss is the expected value of a random variable. Now, the expected value of a random variable. So let us see the formula first and then we will understand. Now, if I tell you that if say for example a person is appearing for a particular think of it, the person is appearing in a reality show, like you must be watching so many reality shows where there is a prize money. Okay, so if it is like this, that if he wins, or if he wins the prize money, say if he is successful in that reality show, okay, so the probability of success, just write these points, you can just use pen and paper and solve it. Say if I say that the person will get a prize money of 10,000 rupees, I'm just writing it 10,000 rupees, and the probability of success is 0.6, that is 60% chance that he will be successful. If he is successful in the quiz, or if he is successful in the reality show, reality contest, then he will get a prize money of 10,000 rupees. But if he fails, then he will get only 2,000 rupees. Okay, so what are the points I have said? It's a reality show. If the person wins, the probability of winning is 0.6, 60%, 0.6. If he wins, then he will be getting a prize money of 10,000 rupees. Now, if he loses, if he fails, or if he is not successful, he will get only 2,000 rupees. So what is the mathematical expectation? So in this simple example, please see the probability is from the study material. We have reproduced the formula here, sigma pi xi. So what we have to do, we have to multiply the probability and the value which he is going to get. And we have to find the summation. So in this case, step number 1, what I will do, the probability of success is how much? 0.6. If he is successful, how much money will he get? He is going to get 10,000 rupees. So I will first multiply this probability and the amount. So I will write 0.6 into 10,000, that is 6,000 rupees, number 1. So I am writing number 1. The second situation can be if he fails. If he fails, then he will get only 2,000 rupees. Now, if he fails, what is the probability of failure? The probability of success is 0.6. So the probability of failure is how much? It is 0.4. How do you get 0.4? 1 minus 0.6. Because you know, in a reality show, there can be two situations, either you are highly successful or not. So it's like a mutually exclusive and exhaustive event. So if 0.6 is the probability of being successful, then the probability of failing or unsuccessful is 0.4. And if the person fails, that is, if the person is not successful, he will just be given 2,000 rupees because he has taken the efforts to come to the studio, participate. He will just get a consolation prize of 2,000 rupees. So I will take the second case now. Probability is 0.4 and the amount he is getting is 2,000. So let me multiply this. 0.4 into 2,000. 2 by 5th. 0.4 is 2 by 5th. 2 by 5. Okay, so I am getting, this is equal to 800. Just check whether we are getting it correctly. So we have got two values here. The first product is how much? 10,000 rupees into 0.6. That gives us 6,000 rupees. And the second product is the probability of failing is 0.4 and the amount you are getting is 2,000. So the product becomes 0.4 into 2,000, that is 800. Now just summation, that is add them. So we are getting 6,800. 6,000 rupees plus 800 rupees, we are getting 6,800. This becomes the mathematical expectation. Excellent. So many of you have answered it. Jyoti, yes. Bhumika is the first, I think, in the chat box. She is the first to write success 6,000, losing 800. Very good. This is Bhumika, the first to write. Shiva has also given the answer. 6,000 is the mathematical expectation of being successful. But Shiva, the second answer you have given, please check the answer. 2,000 rupees he is getting if he is unsuccessful, but you have to find the product of the probability and the amount. So the probability of failing is 0.4. Okay, that is 2 by 5. So you multiply 2 by 5 into 2,000 rupees, you will get 800. So the total amount is 6,800. This is expectation. Okay. So we will look at, and of course, we will see that In the case of expectation, again, there is a small formula, and that is regarding the positive square root of variance. You know the standard deviation, and here again, the expected value is also given. We will take this through some practical examples. Now, the last important point, you remember we did the same when we discussed about the measures of dispersion, and the point was that if you are given the, like in the last chapter, if you are given the, say, the range of x, and you know the relation y equal to a plus bx, then what will be the range of y? Similarly, in this example, in this chapter also, the same concept is there. If y is equal to a plus bx, and you know that you have to find the expected value of y, and you know the expected value of x. So the formula will be mu y is equal to a plus b mu x. Okay, so please note here mu is basically the expected value. Mu y is equal to a plus b mu x. And the standard deviation of y, you can see these formulas are in the study material. We are following the study material point by point. You can see the standard deviation of the formula, the standard deviation of y is given by modulus b into sigma x. Okay, so the standard deviation of y will be given by mod b, that is modulus b into sigma x. So please remember and please write it. I am also having a piece of paper. I'm writing the important formula. So it helps me when we solve the problems. We will be able to refer to the formula. And the first formula is mu y. Mu y is equal to a plus b into mu x. First formula. And the second formula is sigma y is equal to mod b into sigma x. So if I just give a simple example here, say I state that the equation is y equal to 10 plus 3x, y equal to 10 plus 3x, just write 10 plus 3x or 3x plus 10, whatever. Y is equal to 3x plus 10, and it is given that the expected value of x, that is mu x is equal to 7. Mu x is equal to 7. Then what is the expected value of y? Just work it fast and let's see who is the first to write the answer in the chat box. Okay, so the equation is y equal to 3x plus 10, y equal to 3x plus 10, and mu x, that is the expected value of x, is 7. You have to find the expected value of y. So let's see who is the first to do it. So I'm also working on it. So the formula is y equal to 3x plus 10. In this case, the equation is y equal to 3x plus 10. And the formula for finding out the expected value of y is equal to a plus b mu x. Expected value of y we can get when we get a plus b mu x. So here, a plus b mu x becomes 10 plus 7 into 3. So 7 into 3 is 21 plus 10 is 31. So I'm getting the value as 31. Okay. Yeah, many of you answered. Chandan also answered the last question, 6,800. Jyoti, yes, 6,800. Great. Okay. 31. Thank you. Thank you. Bhumika, Manisha, Ankit, so fast. Very good. Excellent. Right. The answer is 21. Plus 10, 31. Yes, very good. Okay. Expected, now some simple theorems are there in the study material which we review one by one. Expected value of a constant k is always k. That is very clear. It is self-evident. And expectation of sum of two random variables, that is e into x plus y, expectation of x plus y, please see the slide. It is equal to the sum of their individual expectations. So it becomes ex plus ey. Okay, so these are simple formula. This you need to remember, of course. Also, expectation of kx. Expectation of k into x is equal to k comes out, k into expectation of x. So just go through these formula and we will now proceed to some of the problems. And of course, The product again is simple. E into xy, that is expectation of x into y, is equal to the product of their individual expectation. So please see the beauty of mathematics here. It's very similar formula. Expectation of the sum of x plus y is equal to the sum of their separate expectation. So ex plus y is equal to ex plus ey. You can see here. I'm moving the cursor here. And ex into y is equal to ex into ey. Okay, so this will be useful for you when you solve some problems. Okay, now let us take this wonderful example from the study material from the Board of Studies. In a business venture, a man can make a profit of 50,000 or incur a loss of 20,000. Okay, so please see, it is a question of success or failure, profit or loss. The probability of making profit or incurring loss from the past experience is 0.75 and 0.25. So what is his expected profit? That means his expectation, mathematical expectation. So let us try to solve it. Yes. So many of you have got 31. Great. Bhumika, Mansi, Shiba, Chandan, Divya. Very good. Okay. Ankit. Right. Ankit, we are getting 21. Please note the formula was, you remember, mu y is equal to a plus b into mu x. So when it is given that mu x is 7, mathematical expectation is 7. And if you see, the relation was y equal to 3x plus 10. So here b is 3. So b into mu x becomes 3 into 7, that is 21. Plus you have to add the 10 because the relation was y equal to 3x plus 10, right? So you can get 31. Now let's try this one, 16.29. So here you can see the profitability. First, let us try to solve it and then we will see the working notes. So you have 50,000 rupees profit, or the person can incur a loss of 20,000. So there can be two situations. First situation, let us write 50,000 is the profit. So I'm writing 50,000 is the profit. Okay. What is the probability of getting 50,000? That means success. The probability is 0.75. So first situation, just find out the product of the probability and the amount of his gain, of his profit. So 0.75 into 50,000. So let's just calculate. And the second situation is what? The second situation is that he incurs a loss. Okay. Now when it comes to the loss factor, can you just see the probability? The probability of loss is 0.25. And if he loses, he can incur a loss of 20,000. Now, please be very careful. 20,000 is a loss. So we should write it as minus 20,000. So minus 20,000 into 0.25. So if you now find out the individual product, 50,000 into 0.75. So let's just work it out. 50,000 into 0.75. So we are getting 37,500. Please work out with me. The second situation is what? If he incurs a loss. The loss is 20,000 loss. Okay. So if the loss is 20,000, then the probability of losing is 0.25. Okay. So the probability of loss is 0.25 into probability is 0.25. Loss is 20,000. So the product is 20,000 into 0.25. So what is 20,000 into 0.25? What is the amount we are getting? So you can see it is minus 5,000 because we have taken minus 20,000. The loss, to show the loss, we have taken minus 20,000. Okay. So therefore, we are easily getting the answer 37,500 minus 5,000. That is, I am getting the answer 32,500. And you can see the working out in the slide. Many of you have got it correct. Great. Ankit, Priyanka, Archana, 32,500. Very good. Bhumika. Dhyanesh also. Very good. Excellent. Okay. Zishan, I have seen the query. Please try to send this query to the Board of Studies. They will try to take the corrective action. Okay. Okay. Yeah, expected value. Very good. Excellent. Jyoti, Manish, Chandan has also written the formula and the entire working out. Great. Very good. Superb. Very good. The next question, a number is selected at random from a set containing the first 100 natural numbers, and another number is selected at random from another set containing the first 200 natural numbers. What is the expected value of the product? Okay. So that means we are selecting a random number from a set containing the first 100 natural numbers, and another number is selected again from another set containing the first 200 natural numbers. Okay. So when we are selecting the say for example, when we are selecting this first 100 natural number, we have to find out the probability, and then again when we are finding the first 200, another number is selected at random from another set containing the first 200 natural numbers. So here again, if you look at the way in which we can select, so we have the values will be like this. So we are getting the probability of selecting one number from the first 100 natural numbers is 1 by 100. Please see the solution which is there on the slide. You can see the probability is 100, 1 by 100. And what happens is when you are selecting any number, the question is the number is selected at random, and another number is selected at random from another set containing the first 200 natural numbers. What is the expected value of the product? So here you can see that in the first case, it becomes the probability is 1 by 100, and then we are multiplying that by the value, that is the summation n into n plus 1 by 2. So we are getting the product is 101 by 2, the first situation. Similarly, in the next case, we are getting the probability one number out of first 200 natural numbers, and then again by the same formula we are getting 201 by 2. And once we are getting these two figures, once we are multiplying, we are getting EXY. We know EXY is equal to EX into EY, expectation of X into expectation of Y. So we are getting the product. So this is from the study material. Okay. The formula we have already checked. Let us now come to the last part, and that is we will look at the different type of questions from the study material exercises so that we can solve it. Okay, also Janalakshmi, Mayur, Jyoti, Jha, Mansi Kumari, they have all given the right answers. Excellent. On the question on expectation. Achha, now let us take the first question here. Probability of getting a head when two unbiased coins are tossed. How much? So please note, this question is number 46 from set A. The probability of getting a head when two unbiased coins are tossed. So two coins are tossed. Please see the logical reasoning part. Two unbiased coins are tossed simultaneously. So the question is probability of getting one head per head. So the situations can be, please see, it can be head and tail. So it can be head and tail. It can be two heads, head and head. It can be two tails, tail and tail, T and T, and it can be tail head. So head, tail, HT, TH, HH, and TT. Now, that means there are four possibilities. And we know that the probability formula is a fraction. The highest value is 1, the lowest value is 0. It's a fraction. And in the denominator, we will write the number of possible cases. Here, the number of possible cases is 4. So denominator becomes 4. But now the question is probability of getting a head. One head is possible when you are getting HT or TH. Okay. Therefore, the probability becomes 2 by 4, that is 0.5. So option number B, 46, option number B is the right answer. Okay. I hope you have followed it. It becomes 46B. Yeah, very good. Many of you have correctly answered. Archana, Dhyanesh, Ankit, Divya, then Priyanka, Mansi, very good. Excellent answer. The next question is also very, very interesting from the study material. A bag contains 15 1 rupee coins. So 15 1 rupee coins, 25 rupee 2 coins, and 10 coins are there, rupee 5. Now, if you select a coin, if one coin is selected at random from the bag, then the probability of not selecting a 1 rupee coin is how much? the probabilities are given. Okay, if you are selecting one coin from the bag, what is the probability of not selecting a 1 rupee coin? So please note here the number of, first please see there are 15 1 rupee coins. I'm writing the number 15. Okay, 1 rupee coins, 25 2 rupee coins, so and 10 5 rupee coins. So what is the total number of coins we are getting? 15 plus 25 plus 10. So that gives me 50. Total number of coins is 50. So you have 50 coins. The question is probability that 1 rupee coin is not selected. So we will try to use the concept of complementary event. So first, let us try to find out the probability of selecting 1 rupee coin. The question says that 1 rupee coin cannot be selected. But first, we will try to find out the probability of selecting 1 rupee coin. You have total 50 coins. 15 1 rupees, 25 2 rupees, and 10 5 rupees. So 15 plus 25 plus 10, it gives us 50. Okay. So once we have 50 coins, okay, you are selecting 1 rupee coins. How many 1 rupee coins are there? 15. So the probability of selecting 1 rupee is 15 by 50. So 15 by 50 means 3 by 10. That is 30%. But the question is not selecting 1 rupee coin. So we find the complementary, the probability of the complementary event. The complementary event is not selecting 1 rupee coin. So the probability becomes 1 minus 30%, that is 70% or 0.7. So the answer of 49 is option number B. Yeah, many of you have done it correctly. I will just share some of the names. So Jasprit, Priyanka, Jyoti, Shiva, Dhyanesh, Archana, they are all very fast in answering. Very good to see that you are all working together and you are getting the right answers. Okay, now let us take the third case. The third problem we are solving is question number 50. A, B, and C are 3 mutually independent events with probability 0.3, 0.2, and 0.4. What is P, A intersection B intersection C? A intersection B intersection C. So you can easily guess this is a very easy question. If you get such a question in the exam, I'm sure all of you will get it right. So they are 3 mutually independent event. Independent event means what? PAB will be equal to PA into PB. If it is dependent, then we will use conditional probability. That is PAB is equal to PA into PB by A. But here it is independent. It's totally given. Please see it's given 3 independent events. Probability is given. So the product, that is probability of A intersection B intersection C, is just the product of all these 3. So it is, let me just write it down and let us try to solve it. 0.3 into 0.2 into 0.4. So you are getting 4 to the 8, 3 is the 24. So the answer is 0.024. I'm sure you have got this correctly. Question number 50, let us see. Yeah, also Balas and Jan Lakshmi, Ankit, Bhumika, they have all got the last one correct, 70.70. Shiva has also given the working out, selecting 15 by 50, 3 by 10, then not selecting 70. Excellent answer. 50th question, many of you have got it right. Excellent. It's coming to 0.024. Very good. Jyoti, Ankit, Manisha, Priyanka, Archana, Bhumika all have got it right. Excellent. Okay. Now let's take the next question. If 2 letters are taken at random from the word home, H-O-M-E, home, what is the probability that none of the letters would be vowels? Okay, this is such a beautiful question. Now home, H-O-M-E, how many vowels are there? We have 2 vowels, O and E. So the question here is, options are given of course. So you can see that here the question is given that what is the probability that none of the letters would be vowels? So we are having, ultimately if you see, we are having out of 4 letters. Now, first of all, the question is 2 letters are selected at random. So what is the probability that none of the letters would be vowels? So here, if you see that the total number of ways in which we can select the two letters is how much? 4C2. There are 4 letters, H, O, M, and E. There are 4 letters. So how many ways can you select 2 letters out of 4? So it is 4C2. That is just a question of combination. 4C2 is, we are getting 4C2 is equal to, we are getting 4C2 is 6. So in the denominator, we get 6. And now the question is, none of the letters are vowels. So we are going to select the 2 letters basically from the 2 letters available, H and M, because O and E cannot be selected because they are vowels. So now we are selecting 2 letters from 2 letters. So it is 2C2. So H and M. So in the numerator, we are writing 2C2. 2C2 is 1 and 4C2 is 6. So the formula you know, the probability formula. So we are getting the answer 1 by 6. So 51, the correct answer is option A, that is 1 by 6. Okay. Now let us take the next question. Again, a question based on a particular formula which we have already done in the theory part. The question is, if X and Y are random variables having expected value 4.5 and 2.5, then what is the expected value of X minus Y? So we have done the direct formula. You remember I was drawing your kind attention to that. Ultimately, the way in which we solve this is the expectation of EX plus Y is equal to EX plus EY. Similarly, the expectation of EX minus EY will give you the expectation of EX minus Y. So here you know the expectations separately of X and Y. It is 4.5, that is expectation of X. If you write EX is how much? EX is 4.5. And EY is how much? It is 2.5. So what is the expected value of X minus Y? We just subtract these two. So it is 4.5 minus 2.5. The option, let's see the options, 2, 7, 6 or 0. So you can easily get the answer. The correct answer is EX minus Y is equal to EX minus EY, that is 4.5 minus 2.5. So the correct answer is 2. Okay, I hope you have also been able to follow this very simple formula. Based on the direct formula, we are solving this particular problem too. Yes, Priyanka has already written the answer too. The next question, if variance, please see this is a very, very important question from the exam point of view. If the variance of a random variable X is 23, then what is the variance of 2X plus 10? Let us see the 4 options. If variance of a random variable, please note the word is variance. If variance of a random variable is 23, X is 23, then what is the variance of 2X plus 10? Now we have seen the formula that in the earlier example which we were discussing. Now if Y is equal to A plus BX, then the standard deviation of Y will be mod B into standard deviation of X. Okay, standard deviation of X. So here it is given. In other words, I can say that the variance of Y, var Y, is equal to B square into the variance of X. So here the variance of X is 23. B is how much? Please see the equation is 2X plus 10. Y equal to 2X plus 10. So here B is 2. B is equal to 2. So if B is 2, modulus B is 2. So B square is how much? B square is 2 square, that is 4. And therefore, the variance of Y, that is the variance of 2X plus 10, is equal to 4 into 23. So the answer should be 23 into 4, which gives us 92. Okay, so variance, please see the working out. Variance is equal to B square into the variance of Y, X. Here, the variance of X is how much? The variance of X is 23. Okay, it is 23. And B, which you see here, B is this 2. So 2 square is 4. 4 into 23 is 92. So question number 54, if you see the answer, we are getting the answer equal to 92. Okay, the answer is 92, right? Because it's a question of variance, so we will take B square. 55, 55th question is, what is the probability of having at least 1/6 from 3 throws of a perfect dice. So we are throwing the die 3 times. Okay, it's a perfect die. We are throwing it the die is rolled 3 times. Okay, 3 times. Now the question is, we have to find out what is the probability of getting at least 1/6. At least 1/6. Please note, at least 1/6. Now we can use the complementary event. Okay, the concept of complementary event. So the probability of getting at least 1/6 is equal to 1 minus probability that 6 will not come. So please try to use this approach when you get problems of this type. Okay, so here the probability of getting at least 1/6, you are throwing the die 3 times. How many times? 3 times. So at least 1/6 means what? At least 1. It can be more than 1, that is 2 times, 3 times. So the best way to do this problem is by using complementary idea. So the probability, we will first find out the probability that 6 will not come. We are throwing the dice 3 times, 6 will not come. Once you find the probability, then if you subtract that probability from 1, then you will easily get the answer to the required question. So first let us find out the probability that 6 will not come. Now what is the probability that 6 will not come? So you are throwing the dice once, first time. What is the probability that 6 will not come? That means the probability that 6 will not come, it means what? Which numbers can come? 1, 2, 3, 4 and 5. So you have 5 favorable cases. So the probability of not getting a 6 is how much? 5/6. This is first throw. Second throw again you are doing. So again the probability is 5/6. And third time also 5/6. So the probability is 5/6 cube. 5/6 into 5/6 into 5/6. 3 times. So therefore the probability that we will get at least 1/6 will be given by 1 minus probability that 6 will not come. That is 1 minus 5/6 cube. So if you work it out, you can just simplify and get the answer. So 1 minus 5/6 cube. So this type of problems, it is better if you can solve using this complementary idea. Okay. Okay, the last question, question number 54. Many of you have got it right. Jaspreet, Shiba, okay, then Dhyanesh 92, Shashi, then we have Chandan, K. Chandan Patro, Ankit Kumar Mishra got 92, Ankit Prasad, thank you. Divya, I hope you are, I'll explain it once again. And this question also many of you have got it. 55, Shiba, Jaspreet, Bhumika and Priyanka, great. Now, if you look at the last question, this request has come from Divya. I will explain the question once again. Please see the question is on this slide only. So, if a variance of random variable x is 23, what is the variance of 2x plus 10? So, please remember the equation was y equal to a plus bx. Y equal to a plus bx. So, here y is equal to 2x plus 10. Y equal to 2x plus 10. So I can write it as y equal to 10 plus 2x. 10 plus 2x. So what happens here? B becomes 2. What is the value of b? B is 2. Now the formula is the standard deviation of y will be equal to b into standard deviation of x. So if I want to find the standard deviation of y, it is equal to b into standard deviation of x. So I can say that the variance of y is equal to b square. If I square both the sides, standard deviation square is variance. If you just find out the standard deviation, if you square it, you will get the variance. So the variance of y is how much? The variance of y will be b square into variance of x. Here the variance of x is 23, b is 2. So b square is 2 into 2, that is 4, and you have variance of x is 23. So b square into variance of x is 4 into 23, as you can see in the working out. So you get the answer of 92. So I hope you are now clear. This question was from Divya Shivekar. I hope you are clear. Yes. Ankit, Priyanka, Ankit Kumar Mishra, all they have got it correct. The last one, 55. Now we are entering into set B. Let us look at the questions in set B now. If two unbiased dice are rolled together, what is the probability of getting no difference of points? Lovely question from the Board of Studies. No difference of point. So you are throwing two unbiased dice. What is the probability of getting no difference of points? Now please note, these are very important questions for the exam. I request all of you to please, as you are doing it, I congratulate all of you for putting the hard effort, hard work and doing it with doing the problems together with me. So this should be the spirit. Keep up the spirit and please let us work together for the remaining questions so that you are absolutely clear on this chapter. This question is, we are trying to roll two dice. The probability of getting no difference of points. Now, two dice when you are rolling, if you roll one dice, how many outcomes can we get? How many events? 6. There can be 6 situations. Similarly, when you are rolling another dice, the total number of cases will be 6 into 6. So in the denominator, we are getting 36. But the question is, what is the probability of getting no difference of points? No difference of points you will get only when you get 1, 1. That means no difference means what? The two dice will have the same number. The number which you get at the top when the dice is rolled will be same. This can only happen in the following ways. Either 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, or 6 and 6. So if you see, I'm just moving my cursor. There can be 6 situations. 1, 2, the third situation, fourth situation, fifth, and 6. So there are 6 situations, 6 ways. So the total number of possible cases is 36. The total number of favorable cases is 6. So the probability becomes 6 by 36, that is 1 by 6. So this is the logic and the working out. Right? So this is a very important question for the exam. Very intelligent question also. And this is, now there is one question, unbiased. Jana Lakshmi has asked, what do we mean by unbiased? Okay, unbiased means that if you throw the dice, any side can fall. Okay, you may remember the history. I will take you once for a few seconds to Mahabharata. In the story of Mahabharata, you may remember the Pandavas lost the dice because the dice was manipulated by the Kauravas. It was biased. Okay, you must have seen Mahabharata in TV also. So unbiased means it is not manipulated. It is absolutely perfect dice. And if you throw the dice any face, you can get any of the point with equal likeliness, equal probability. That is why it is called unbiased. The next question, A, B, C are 3 mutually exclusive and exhaustive events such that probability of A is equal to 2 into probability of B is equal to 3 into probability of C. So it's a beautiful question once again from the Board of Studies. Very important. These type of questions are expected in the exam. So let us try to find out the solution. Please note, the hint is given in the problem. They are 3 mutually exclusive and exhaustive events. So you can easily find out they are exclusive. That means if one takes place, the other will not take place. And the hint is given, they are exhaustive. Exhaustive means what? The exhaustive means that the probability of A, PA plus PB plus PC equal to 1. So we can write PA plus PB plus PC equal to 1. But if you see it is given, it is already given that PA is equal to 2 into PB, that is equal to 3 into PC. So I can write in this way, I can just write in this way that PA is equal to 2 into PB. PA is equal to 2 into PB, and it is also given that PA is equal to 3 into PC, 3 times the probability of C. So if I move all of them into the probability of B, so I can easily, if I just convert them into probability of B, I can write PA is 2PB. So I've taken 2PB here, PB as it is, and for probability C, you can see the formula, the relation given is 2 into probability of B is equal to 3 into probability of C. So I can write probability of C is equal to 2/3 into probability of B. So I've just made this change here. Together the probability is 1 because it is given in the problem that they are exhaustive. So I am getting 2 PB plus 2/3 PB. The total I am getting is equal to 1. If this is equal to 1, so I am getting the probability of B equal to 3/11. Just work it out. I'm also working out once again. You will get the probability of B equal to 3/11. So this is what the question says. So the answer is option number B is the right answer, 3/11. Very, very important question for the exam, 3/11. Okay. Janlakshmi, I hope you have understood. Thank you. You have written thanks. Jaspreet, yes, 3/11. And also Mansi Kumari has given the right answer, 3/11. Very good. The next question for two independent events, I am taking question number 12 from set B of the study material. For two independent events A and B, what is probability A plus B when it is given that probability of A is 3/5 and probability of B is 2/3? It is told, please see it is written that it is independent event. That means what? That means probability of AB is equal to 3, probability of AB is equal to probability of A into probability of B. That is PA into PB. Okay, it is independent. What is the probability of A? 3/5. So you can see 3/5. Okay, the probability is 3/5. What is the probability of B? It is 2/3. So just multiply 3/5 into 2/3. So we have got 3 and 3 cancels. I am getting probability of AB equal to 2/5. Just check it, 2/5. So now you have to find PA plus B. What is the formula of PA plus B? PA plus B is equal to PA plus PB minus PAB. So now just let us put on this formula. Just let us write down the value. PA is how much? 3/5. So I write 3/5. PB is how much? 2/3. So I'm just writing 2/3. Minus PAB. Minus PAB. PAB is how much? We have got 2/5. So the answer is 3/5 plus 2/3 minus 2/5. Just let us find out the LCM. It is 15. So it is 9 plus 3, 5 to the 10 minus 6. So it is, I'm getting 13/15. I'm just checking the working out. Yeah, the answer is 13/15. Just check it. It's again a very intelligent question based on all the discussions we had. Yes, answer is 12B, 13/15. Okay. Acha, let me, Bhumika, I will explain the last one once again. Just give me a minute. Yeah, let me see. So let us see how we are doing it. Okay. You can just use the formula. You see the relation is given 2PB equal to 3PC. Okay, just use it. 2PB equal to 3PC. So we are trying to get everything in terms of probability B. The relation is given 2PB equal to 3PC. That means we can write PC is equal to how much? 2/3. 3 comes down. So it becomes 2/3 into PB. And this is what we have done. Instead of PA, probability A, instead of PA, we have written 2PB, this relation. PB remains as it is. PC, instead of probability C, we have written 2/3 into probability B. And therefore, it's equal to 1 because A, B, C all are exhaustive. They are exhaustive events. That means the sum has to be equal to 1. So we are getting the probability of B from there. Okay, I hope you have understood. Just see the relation which is given. PA equal to 2PB equal to 3PC. So just take this second part, 2PB equal to 3PC. That means if I write that 2x equal to 3y, 2x equal to 3y, then y is equal to how much? It is 2/3 into x. 2x equal to 3y, then y is how much? 2x/3 or 2/3 into x. Okay, that is the relation. Question number 12 is done. Now we are taking question number 15. Okay. Question number 15. For two independent events A and B, it is given two independent events A and B. P A union B is 2 by 3. P A is 2 by 5. What is P B? So try to do it yourself. Okay. Please try and work it out yourself and see if you can get the right answer. Okay, I have repeated 8th question. Janalakshmi, I hope you are now clear how we have done it. Okay. Two independent events A and B. A union B is given 2 by 3. P A is given. What is probability of B? Have they given? Okay. Just try and see. Two independent events, it is stated. Okay, so I'm also writing it on a piece of paper. Okay, I'm just writing it out and let us see if we can solve the problem. Please work it out and then we will see the solution. P A union B is 2 by 3. We know P A union B is equal to P A plus P B minus P A intersection B. So if I take, we have to find the probability of B. So if I take the probability of B as X, then I can form an equation. It will become P A is 2 by 5 plus X minus 2X by 5. This is equal to 2 by 3. So from here you can get the value. So it becomes X minus 2X by 5 is 3X by 5 is equal to 2 by 3 minus 2 by 5. So it gives us 4 by 15. So we can get the answer. The answer is equal to 4 by 9. Just check. So just use the formula PA plus PB minus PAB and take the probability of B as X. PA you already know it is 2 by 5. PB will be X and PAB will be how much? It is independent. So the product of the two probability. So 2 by 5 into X. Just put the value, you will get the answer. Very simple question. There is no complication here. It's just a direct formula based question given in the problem. And very, very important for the exam. These questions are ideally suitable for the exam. Already many of you have got 4 by 9. Ankit, Vidhi, Jasprit, Shiba. Yes, good. 4 by 9. Excellent. Now we are going to the next few questions for 3 independent events. This is a theory question and it is given in the study material. Also quite important for the exam. For 3 events A, B and C, the probability that only A will occur is what? So only A occurs. What is the correct answer? So only A occurs means B will not occur, C will not occur. So this is, you have to draw the Venn diagram, and from the Venn diagram you will get that B is the answer. That is probability of A intersection B dash intersection C dash. Okay. Now the 19th question is little bit challenging but very interesting question, no doubt about it. This is based on conditional probability. It is given that a family of 2 children has a girl. What is the probability that the other child is also a girl? Okay. Now there are 2 children. Okay, they have got 2 children. So we can say 2 children, one is elder, one is younger. Elder child and younger child. So what is the probability that the other child is also a girl? So let us take the probability that one child is a girl. So one child is a girl, there can be, what is the combination? I am writing boy and girl. It can be first situation, elder child is a boy, younger child is a girl. Second situation can be elder child is a girl, younger child is a boy. So BG, GB. Then the third situation can be both are girls, G and G. And the fourth situation can be both are boys, BB. So how many situations are you getting? How many possible outcomes are you getting? 4 outcomes. Girl, boy, boy, girl, boy, boy, girl, girl. 4. Now the question is, out of these, one child is a girl. at least one child is a girl. How many cases are there? It can happen in 3 cases: BG, GB, and GG. So the answer, the first part is probability of A that one child is a girl is 3/4. So we are getting the probability 3/4. Now the question is, what is the probability that the other child is also a girl? So this is a question of conditional probability. So therefore, what we will do is, if the first one, probability of the first child is a girl, that is the girl child here means 3/4, the probability is 3/4. What is the probability that the other child is also a girl? So here the question is, probability of A is 3/4 and probability of B is 1/4. Okay, so therefore probability of B by A, this B by A is equal to the conditional probability formula PAB by PA. So we are getting 1/3. Okay, so here we can see it's a question of conditional probability. We have found out the probability of one child, at least one child is a girl, that is 3 out of 4. And what is the probability that the other child is also a girl? Other child is also a girl is only possible when you get the combination G and G. Now G and G combination means it is 1/4. Why? Because out of 4 cases, BG, GB, BB and GG, girl, boy, boy, girl, 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 boy, boy, 4 cases. Out of the 4 cases, 2 girls is only appearing in 1 case. So the probability of B, the second event, is 1/4. Now using the conditional value, you can easily get the answer 1/3. So this is also very interesting question, number 19. I have taken the next questions, number 23. 21 first. If a random variable X assumes the values 0, 1 and 2 with the probability 0.3, 0.5 and 0.2, then what is the expected value? So this is a simple question. You can just write it in a single table. I'm writing a small table here. Okay, just try it out on your own. And then we will tally the answers. Random variable X is assuming the values 0, 1 and 2. Probability is given 0.3, 0.5 and 0.2. So the first product is how much? 0 into 0.3. So answer is 0. The second is 1 into 0.5. It is answer is 0.5. The third one is 2 into 0.2. 2 into 0.2 means the product is 0.4. So the total sigma is how much? 0 plus 0.5 plus 0.4. So we are getting 0.9. Just tally the answer. 21, you will get 0.9. Okay. Yes, Shiva, you are right. Probability of both girl child is 1/4. Absolutely. And that's how we solved it. Very good. Okay. Now, Manisha, you have said that, sir, if one girl is already there, so is boy possible? No, boy is not possible because the question is one is a girl. What is the probability the other is also a girl? Okay. So here we have to take the conditional probability here. Boy combination will not be considered. Ankit, I hope you have followed it. The family of 2 children has a girl. What is the probability that the other child is also a girl? So first we are finding out the probability that one child is a girl. At least one child is a girl. Here we are taking the possibility 3/4 because we are considering at least one child is a girl. Okay. Now the question is, what is the probability that the other child is also a girl? Now the probability that other child PB, we are taking the probability of PB. Okay. So probability of PB is, here PB is how, what is the meaning of PB? PB is that the probability of having one child, one girl, only one girl. Now, only one girl, for PA it is at least one girl, and PB is that both are girls. The event PB is both are girls. Both are girls is only possible when you have BG, GB, GG and BB. So only GG case, girl. So that is possible when you have 1/4. Okay, so now from using the conditional probability, we are getting PA. That is, one child is a girl, 3 by 4, and PB is second child is also girl. Because the question is, if one of them is a girl, what is the probability that the other is also a girl? So PA into B by A we are considering. And that B by A we have to find out. Okay, so we are getting it from PAB divided by PA. Okay. Now we are going into the next question here. And we are getting 23. If 2x plus 3y plus 4 is 0 and the variance of x is 6, what is the variance of y? Please see this question number 23, the last question on this slide. If 2x plus 3y is equal to 0, then you have to find the variance of y. It is given that variance of x is 6. Very easy. We have done numerous problems like this. Just rearrange the answer, rearrange the equation here. You can just rearrange the equation. Okay, Ankit, good to see that you have explained. You have understood this explanation. Good. Now, 23. 2x plus 3y equal to 4. Just see in the slide, I have done the step-by-step calculation here, the working out. So I can easily write y is equal to minus 4 by 3. So minus 4 by 3. So I can write y is equal to minus 4 by 3. And from there, we can find out it will be all again minus 4 by 3. So here, Vy, that is variance of y, will be modulus. Modulus is 2 by 3. V here is 2 by 3. So b square into variance of x. Now b square is 2 by 3 square, that is 4 by 9. And the variance of x is given 6. So 4 by 9 into 6. 4 by 9 into 6 becomes 3 3s are 9 and 3 2s are 6. It becomes 8 by 3. Answer is 8 by 3. Okay, now we proceed to the last set, set C, and we will see some final problems before we close this chapter. We complete the discussion of this chapter. So, the question number 2, if an unbiased coin is tossed 3 times, what is the probability of getting more than one head? More than one head. Unbiased coin is tossed 3 times. So the total number of cases can be, sample space is what? HHH, 3 heads. It can be HH tail, tail. It can be head, tail and head. It can be tail, head and head. So the sample space we are getting is, these are the sample spaces. What is the probability of getting more than one head? So more than one head we can get only in these ways. It can be 3 heads. It can be 2 head, 1 tail. So 2 head, 1 tail we have considered. And the question is more than one head. So 2 head and 1 tail, there can be 3 situations, and all 3 heads, only 1 situation. So total number of favorable cases is 4 cases. And if an unbiased coin is tossed 3 times, how many possibilities can be there? So for every coin tossing, there are 2 possibilities. For 3 times, it is 2 to the power 3, that is 8. So the answer is half. 4 by 8, that is 1 by 2. Question number 2, I hope you have understood, it's clear to you. Now the question number 10. This is based on the long formula which we have discussed on the first day. The probability of passing, the problem in probability was given to 3 CS students A, B and C, whose chances of solving it are 1 by 3, 1 by 5 and 1 by 2. What is the probability that the problem is solved? Okay. This is a case where we have to use independent. See, the probability that A is able to solve the problem is independent of B. All 3 students are writing the answer separately. They cannot influence each other. They cannot say, for example, no one is dependent on the other. There's no way to create any impression or any influence. So they don't depend on each other. So the events are independent. Events are independent means their individual probability we know. PA is 1 by 3. Probability that B does it is 1 by 5. And probability that C does it is 1 by 2. So all the probabilities are given. What is the probability that the problem is solved? So first we will have to find out here the sum. The sum is how much? The sum is PA plus PB plus PC minus PAB minus PBC minus PAC plus PABC. Okay, so from there, if you put on the formula once again, you will get PA plus PB plus PC minus AB. This will be minus BC. I'll just make a small change here. So it will be minus BC, B and C. I'll just make B and C here. And okay, now you can just do it and you can just see the answer here. So we are getting PA plus PB plus PC minus PAB minus PAC minus PBC plus PABC. So it's a simple case of calculation. PA plus B plus PC, 1/3, 1/5, 1 by 2. Just add it. PAB is equal to independent event. So it's the product of A and B. So 1/3 into 1 by 5. That gives you PAB. Similarly, you can find PAC and you can find ABC. Just a simple multiplication, nothing else in this problem, just multiplication. So the answer comes to 11 by 15. This is question number 10. Question number 12 is very, very interesting and quite possible to get these type of questions in the exam. Tom speaks truth in 30% cases and Dick speaks truth in 25% cases. What is the probability that they will be contradicting each other? Okay. Contradicting means, the meaning of contradiction is if Tom speaks the truth, then Dick will not speak the truth because truth is only one. Okay, so if Tom says that no, sun rises in the east, Dick will say no, sun rises from the north. Okay, so it's like that. They are contradicting each other. So Tom speaks the truth in 30% case. So probability of Tom speaking the truth is 0.3, that is 3 by 10. Please write it down. Dick speaks the truth in 25% cases. So the probability of Dick speaking the truth, PD, is equal to 2 by 25%, that is 1 by 4. So it's a very interesting question. The question will be like this. If Tom speaks the truth, please note, Dick will lie. And if Dick speaks the truth, Tom will lie. So it's just use of complementary. Tom speaking the truth, situation number 1. Tom speaks the truth, Dick tells a lie. What is the probability? Tom speaking the truth, probability is 3 by 10. Dick's not speaking the truth, that is Dick telling a lie. Dick telling a lie, the probability is 1 minus 1 by 4, that is 3 by 4. Please see here in the slide, 3 by 10 into 3 by 4. This is situation number 1. The second situation is Tom is now speaking the lie. Now the probability that Tom speaks the truth is 3 by 10. So the probability that Tom is lying, it is 7 by 10. 1 minus 3 by 10. And Dick is speaking the truth. 1 by 4. So 7 by 10 into 1 by 4. So we are getting the answer 0.4. Just if you multiply, you will get the answer 0.4. Question number 12, I hope it is clear. Please try to understand the way things, the working out is done. Just check the answer. 3 by 10, I am also working it out. 3 by 10 into 3 by 4, that is 9 by 40 plus, let me just work it out, by plus 7 by 10 into 1 by 4. So I'm getting 0.4. This is what I'm getting. I hope it is the correct answer. Just check the answer in the study material. I'm getting 0.4 as the answer. Once we simplify 3 by 10 into 3 by 4, plus 7 by 10 into 1 by 4, I am getting 4 by 10, which is 0.4. Just check the answer. 12th, just check the answer with the study material. Okay. The next question, a packet of 10 electronic components is known to include 2 defectives. If a sample of 4 components is selected at random, what is the probability that the sample does not contain more than 1 defective? More than 1 defective. It does not contain more than 1 defective. So the sample contains, a packet contains 10 electronic components of which 2 are defective. So we can write out of the 10 electronic components, 8 are good and 2 are defective. Now we are drawing a sample of 4 components. What is the probability that a sample does not contain more than 1 defective? That means maximum number of defective is 1. So out of 4, you can say that if the maximum number of defective is 1, not more than 1. So situation number 1, what is the first situation? 0 defective. 0 defective, all 4 are good. Second situation is 1 defective and 3 are good. Okay, so that is what I have written. Either situation number 1, 3 are good, 1 is bad, or all 4 are good. Now, situation number 1, 3 good and 1 bad. How many ways can you do it? So it is just a question of combination. So we use the theory of combinations. So for the first situation, please note, 3 good items you can select from 8 items in 8C3 and 1 is bad. So out of 2 defectives, you can select 1 bad item in 2C1. So 8C3 into 2C1 divided by 10C4. Why 10C4? Because there are 10 items, you are selecting 4 of them. It can be selected in 10C4 ways. So in the denominator, you have 10C4 plus second situation. Second situation is very simple. All 4 have to be good. All 4 are good means what? Total number of items are 10, out of which good items are 8. So if all 4 are good, that means it is you are drawing 4 items from 8 items, that is 8C4. The denominator continues to be 10C4 in the second situation also. So if you have understood this, just work it out. You should get 13 by 15. So 8C3 into 2C1 plus 8C4, you will divide it by 10C4, you will get 13 by 15. This is also very intelligent question, just a question of combination. 15th question. Yes, many of you got it correct. Okay. Chanalakshmi, you did not get 12th sum. See, contradiction. Tom is speaking the truth. If Tom is speaking the truth, then please note, if Tom is speaking the truth, then Dick is lying. You know their individual probability. So when Tom speaks the truth, the probability is Tom is speaking the truth. What is the probability that Tom speaks the truth? Just check the problem. 3 by 10. So Tom speaking the truth is 3 by 10. Dick speaking the lie is how much? 1 minus 1 by 4. Because the probability of Dick speaking the truth is 1 by 4. So the probability that Dick is telling a lie is 1 minus 1 by 4, that is 3 by 4. Situation 1, Tom is speaking the truth, Dick is lying. Situation 2, Tom is lying and Dick is speaking the truth. You're getting it. So it's just complementary. Tom speaks the truth, Dick tells a lie. Situation 1. Situation 2 is Tom is lying and Dick is speaking the truth. So in the first case, probability is Tom is 3 by 10, Dick speaking a lie, telling a lie is 3 by 4. So the first situation is 3 by 10 into 3 by 4. Please see the working out in the slide. Second situation is now Tom is lying. Tom is saying something wrong. Tom is saying a lie. So his probability of speaking the lie is 7 by 10. And Dick is speaking the truth in this case. So it is 1 by 4. So you can get the answer. Please note in these two combinations only, the answer will be a contradiction because one is telling lies, one is telling the truth. If both are lying, then they are not contradicting each other. If both are saying the truth, then also they are not contradicting each other. So contradiction will arise only when one speaks the truth, the other tells a lie. Okay. So I hope you have understood, Janlakshmi. Okay. The last few questions we take. And this is, let me check. If X and Y stand in a line with 6 other people, what is the probability that there are 3 people between them? This is also quite interesting. So X and Y stand in a line with 6 other people. So there are 8 people now. So the way in which 8 people can stand is 56 ways. And the possible cases, if you work it out, you'll get 8 ways. So the answer is 1 by 7. 8 by 56, that's equal to 1 by 7. 18th question is PA equal to half, PB is 1 by 3. PA intersection B is given. You have to find PA dash slash B dash. This is just formula based. You can just work it out and you will get the answer. Okay, so just based on the formula. Okay. 4 digits, this is from MTP. Very similar to the MTP problem. 4 digits, 1, 2, 4 and 6 are selected at random to form a 4-digit number. what is the probability that the number so formed would be divisible by 4? So 1, 2, 4 and 6 are selected at random. You know that 4 digits, 1, 2, 4 and 6 can be arranged in how many ways? 4 into 3 into 2, 24 ways. Now out of these 24 permutations, you can see 24 orders. If it is divisible by 4, that means the last 2 digits should be divisible by 4. That means the last 2 digits should be either 12 or 24, or it can be, do we have any other combination? It can be 64 also. If it is 64, 24, then it is divisible by 4. Okay, so 12, 24 and 64, then it is divisible by 4. So if you just work it out, you will get the answer. Total cases is 24. Favorable cases we see is if it ends with 12, 24 and 64. So there are 2 cases in each. So you get the answer 6 by 24, that is 1 by 4. This is 19th question. The 23rd question, if a bag contains 6 white and 4 red balls, if a person receives 10 rupees and 20 rupees for a white and red ball respectively, what is his expected amount? This is also a simple question. 6 white and 4 red balls, you are drawing 2 balls. So the total weigh will be 10C2. Total 10 balls are there. 6 white and 4 red, total 10 balls. You are drawing 2 balls, so 10C2, 45 ways. Now, the question is, you are receiving 10 rupees for a white ball and for 20 rupees for a red ball. So, if 2 are white, if both the balls are white, the combination is 6C2, that is 15. If white or red white, then we are getting 6C1 into 4C1. That gives you 24. And if both are red, we are getting 4C2, that is 6. So therefore, the expected value I have worked out step by step here. You can see step by step working is given. So the expectation is WW, or it can be WR, white and red, or it can be red and red. So the case is 10 rupees, 20 rupees. So 10 rupees into 15 by 45. So 15 is when you are getting 2 white balls. Please note, it has become 20 rupees now because you are getting 2 white balls. You will get 30 rupees basically for a red and white ball. So red and white balls, 30 into 24 by 45. And 2 red balls means 10, 20 and 20 rupees, 40. So 40 rupees into 6 by 45. So you are getting the total answer. The final answer is 28. So the option number D, I think, is the right answer. Just take the option 23. So it is getting, the answer is 28. This is a very intelligent question, definitely. Yeah, Jasprit, Shiba, Priyanka, good. They have got the right answers. Great. Now we take the last 3 questions. What is the chance of picking a spade? This we had done. So this also we had already done the last day. This is from the NTP once again. If 3 events ABC are mutually exclusive, exhaustive and equally likely, what is the probability of the complementary event of A? That is very simple, we did it. All the 3 events, the sum of the probability of the 3 events is equal to 1. Okay. And if all 3 are equally likely, that means each of them have a probability of 1 by 3. So the probability of A, PA is 1 by 3. So if the probability of event A is 1 by 3, then definitely the complementary event is 1 minus 1 by 3, that is 2 by 3, as you can see on the slide. 82nd question, which came in the MTP, this we had already done. The answer was 16 by 52, that is, I think it comes to, the probability is given, it comes to 4 by 13. Okay. This also we had done, CA, BCom, this we had done. Rupesh is known to hit a target. These questions are very important. We had done it. Please see the last day's video once again. We did this one, Rupesh and David hitting a target. So these came in the MTP also. Apart from the study material, it's also there in the MTP. So you can understand how important it is. Okay. This also we have just done. ABC are 3 mutually exclusive events. We were doing that. I explained this question once again. So these are the important questions which you should keep in mind. The question on variance we are also done. 2x plus 3y plus 4 is 0. So these are very, very important questions. I once again bring it to your kind notice. And This is done again. Okay. Acha, what is the probability that 4 children selected randomly have different birthday? So we are going to close with this question. Just see, this is a beautiful question. What is the probability that 4 children selected randomly have different birthday? So say the first child, there are 4 children. The first child has any birthday. So say the birthday is 20th June. Okay. So the second child to have a separate birthday. So the first child, if you see, the probability is what? 365 by 365. So he can take any type of birthday. 365 by 365. That is 1 basically. The second child must have a different birthday. So how many days are left now? 364 days are left because the first child, let's call them A, B, C, D. So A's birthday is already gone. So we deduct 1 day out of it. So now there are 364 days. So B's birthday must fall in 364 days out of 365. So probability of B is 364 by 365. So A and B are now gone. Now you are left with C. C's birthday must fall in the remaining 363 days, 1 day less. And D's birthday must fall in 362 days. So it's a long calculation. If you multiply all this, 364 by 365 into 363 by 365 into 362 by 365, it comes to around 98.36. This was a very interesting question from the Board of Studies. Okay. This we have just done, very similar to this question, divisible by 5. Okay, and okay, let's try this one. I'm taking, after exhausting most of the questions from the study material exercises, after solving them, we are looking into the MTP. Several questions you can see are coming in common, and the more you practice, you see the questions will become more familiar to you. Question number 86, this is an MTP question. In connection with a random experiment, it is found that PA is this, PB is this, PA union B is this. We have to find PA by B. So here PA is known, PB is known, PAUB is known, A union B. So from there you can easily get, using the equation PA union B, you know PA union B is PA plus PB minus PAB. So once you get PAB, just solve it out, you will get PAB equal to 13 by 30. So since you know PAB is 13 by 30, so and PB also you know, PB is given 3 by 5. So you can easily get the answer 13 by 30 divided by 3 by 5, that is into 5 by 3. So it becomes, I think, 13 by 18. I'm getting the answer. I'm getting the answer 13 by 18. 13 by 30 divided by 3 by 5, that is 13 by 30 into 5 by 3. So I'm getting the answer 13 by 18. That is option number D is the answer for this question. Fine, so with this, we end up the discussion on probability. We had covered all the concepts, important concepts, including the exercises set A, set B, set 3. I have tried to point out the important questions, the type of questions important in the exam. And this probability chapter is intelligent. It's composed of a lot of formula, and you need to apply your mind in an intelligent way to understand the problem. And here calculation is not that important. You know, calculation is the primary thing in probability, is to understand and apply the right formula. It's not like calculating tables. You're not creating a frequency distribution. So here the focus should be on understanding and using the right formula and using the right logic also, so that you are able to solve the problem. So please carry on solving the problems. Go through the videos once again. As and when possible, more additional examples we shall be uploading in the portal. And with this, we end this today's session on probability. We have completed 2 sessions on probability. We have also discussed about the random variable, discrete random variable, and continuous random variable. So this will help you in the next chapter, which you will be learning on theoretical distribution. And we have also referred to the continuous probability distribution, which is based on the continuity of the observations within a defined range. And the example of such an observation, such a distribution, is the normal distribution. And an example of discrete probability distribution, as we have discussed today, is the binomial as well as the Poisson. So these will be the subject matter of the next chapter. So wish you all the best in your learnings. Thank you and best of luck.